Alright, so today we are on Unit 1, Lesson 5, Rational Expressions, and this is day 1 of this. So we are going to simplify, reduce rational expressions, and you're like, what in the world is a rational expression? Well, it's going to kind of look like a fraction, except it's going to have some x's and x squareds in there, and to define the domain for various functions. A fractional expression. A quotient of two algebraic expressions. So you've got something like 2x over x minus 1 or y minus 2 all over y squared plus 4. A rational expression is a fractional expression where both the numerator and denominator are polynomials. So basically they're monomials connected by addition or subtraction. So you've got x connected by a subtraction sign down the denominator, and then a 1 is connected to this, so that makes it a polynomial. Or you've got x squared, and then that's just a monomial connected to minus 1, so that makes it a polynomial x squared minus 1 because it's more than one term. Or you've got x squared minus 5x plus 6. You've got 3 terms there, so that's a polynomial. So notice both of those, you got something up in the numerator and something down the denominator, and it's a fraction, so that is a rational expression. So let's look here at domain. Domain is a set of real numbers that a variable is permitted to have. And the variable what we're typically working with here is x. So we're trying to figure out what x is, and sometimes it's easier to figure out what x cannot be. So let's go ahead and let's determine the domain of an expression down here. So you're looking at that fractional expression down there, or that rational expression down there in letter A. There you got x over x squared minus 5x plus 6. Because you have a polynomial down there in the denominator down there, what we have to do is, because we've got an x in the denominator, basically you cannot divide by 0. So we're concerned about is how x squared minus 5x plus 6 there can equal 0. So let's set our denominator here equal to 0. And so when we set that equal to 0, we're noticing, oh yeah, we can factor this. What times what there gives us x squared, x and x. What multiplies to give us 6 and adds to give us a negative 5, that would be minus 2 and a minus 3. So now we can set each of these terms equal to 0. And solve for x. So we can add 2 here, and we get x equals 2. We can add 3 here, and we get x equals 3. So basically our domain, everything is going to work in this except 2 and 3. So what we say there is the domain looks like this. We do these squiggly parentheses here, and we say x such that, so everything will work for x, except x cannot equal 2 and x cannot equal 3. Alright, so let's go ahead and let's find the domain of these. What do? We've got a rational expression where we've got an x down the denominator, so we need to set the denominator there equal to 0. This one here we don't have to factor, we can just simply solve for x. So I can subtract 6, and I get x equals negative 6. So domain, so I do D for domain, and I just do colon there, and then I do my 2 sets of squiggly brackets, and then I say x such that x cannot equal negative 6. So x can be anything, but it cannot be negative 6, because if you plug it in there down the denominator, you get negative 6 plus 6 is 0. And then you'd have negative 6 divided by 0, and we cannot do that. You cannot divide by 0. Alright, so letter C there, again, it's a fractional expression there, or it's a rational expression there. So I'm concerned about there being an x down the denominator, and there is. So since there is an x down the denominator, I'm going to have to set that equal 0 and solve for x. So I'm going to have to add 3. I get 2x equals 3. Divide by 2, and x equals 3/2. So my domain, so I do D colon, do my 2 sets of squiggly brackets, and I say x such that x cannot equal 3/2. X can be anything else, but X cannot equal 3/2, because if you put 3/2 down the denominator, you get 2 times 3/2 there is 3, and 3 minus 3 there is 0 down the denominator. We cannot divide by 0. 3/2 divided by 0, can't do it. So, there's another situation here. For a polynomial, the expression is defined for all values of x. So then we write all real numbers for the domain there as all reals. So if you kind of think about that, all real numbers, that's what the capital letter R there is. Let's go ahead and let's look at this one. So my domain here, it's just 2x squared plus 3x minus 1. They're all single terms. They're connected by addition or subtraction. Notice we don't have a fraction, so we don't have anything down the denominator. We just have this nice polynomial. And it says for a polynomial, the expression is defined for all values of x. So everything will work. So we can just simply say all real numbers. Or you can abbreviate all real numbers there and just do this capital letter R. That means all real numbers. Letter B here, another one here. It's just a nice polynomial there. It says x plus 8 there. And so that is just a polynomial. There's nothing down the denominator. So we can simply say all real numbers. And I just make a fancy R. So you kind of can graph this out if that's a little confusing for you. If you think about this, so if that's what the graph there for x plus 8 there is, all real numbers, what we're saying is x can equal anything. So I can put in 0, I can put in any negative number, I can put in any positive number. That's what the graph there would be, and it encompasses all real numbers. There's nothing that it cannot be. Similarly up here, this one here is going to look like some kind of a quadratic there. And again, it goes up to the left and over to the left forever and ever, and this one here on the right hand side there goes over to the right forever and ever and ever. And so the domain there just happens to be all real numbers. So whenever you have a polynomial there, it's going to be all real numbers. Now, what about square roots? So that's what number 3 there is going to be looking at. If you look down there at your examples down there, they all have square root symbols around them. So it says if x is inside a square root in the numerator, find the domain by setting the expression inside the square root equal to 0 and solving for x. So let's think about that. Let's go ahead and take whatever is inside the square root there, which is an x, and then set that equal to x. Actually, you want to say greater than or equal to x, because then that's just your answer. And let me kind of explain that. If you had a negative number, so any kind of a negative number, and you were to take the square root of that, can you do that? Can you take the square root of -9? No, you can't take the square root of -9. You get an error on your calculator. We can't take the square root of negative numbers. What about the square root of 0? Can we do that? Yeah, that's equal to 0. That works. Can you take the square root of any positive number? Sure, we can take the square of any positive number. They might always not come out very nicely, but we can certainly take the square root of a positive number. When we take the square root of a positive number there, what do we end up getting? So let's, for instance there, let's say the square root of 9. So the square root of 9 there would just give you 3. So, or the square root of 4 gives you 2. The square root of 2 gives you about 1.4. But again, you can find the square root of those numbers. So any positive number will work. So whenever we write our answer here for the domain here, we always want to do this where it's greater than or equal to 0. And then that's our answer. So then we can just write in that nice form I've been showing you. You go squiggly, squiggly, and you do x, and then that line there means such that x is greater than or equal to 0. This time we're writing down what is, not what is not. So again, whatever is inside the square root for the next one here, set it equal to 0, because it can equal 0. Underneath the square root can equal 0. We saw that when we did this over here on the side. It can equal 0, and it can be anything greater than or equal to 0, so let's say it's greater than or equal to 0. So let's add 2 there, and we get x greater than or equal to 2. So then our solution there, let's write that out. X such that x is greater than or equal to 2. So for instance here, if you tried to put in something smaller than 2, like 1 minus 2 there is -1, you cannot take the square root of a -1, because the negative answer will give you an error. But if you put 2 in there, 2 minus 2 is 0, you can take the square root of 0. We said that was 0. Anything larger than 2? Sure, 3. 3 minus 2 is 1. I can find a square root of 1 is 1. So now go ahead and look at the couple examples down there. So you can see that you've got a square root now down in the denominator. So it says if x is inside the square root in the denominator, so whenever x is inside the square root there, we know whatever is inside the square root there, we have to say that's got to be greater than or equal to 0. If it's in the denominator there, we know that you cannot have whatever's down in the denominator cannot equal 0. So because you can't be equal to 0, because it's in the denominator, we're going to eliminate the equal sign there. So we're going to say down the denominator underneath the square root, you have an x minus 3. Normally whatever is underneath the square root, we would say has to be greater than or equal to 0, but because it's down the denominator, we can only say it's got to be greater than 0. So then we can solve for x here, add 3, and we get x is greater than 3. So then our domain for this one here is x such that x is greater than 3. All right, letter B, you can see you've got a square root there down in the denominator as well. So again, whatever is down in the, if it's a square root there, we usually say it's greater than or equal to 0, but because it's down in the denominator, we're only going to say it's greater than 0. Now subtract 3 from both sides, and we end up here getting x is greater than -3. So now let's write our answer out here. The domain is x such that x is greater than -3. So we have one here as well. This time we've got 2 things going on for this one. Notice we've got something going on up here in the numerator. We've got a square root. So remember, we always said whatever underneath the square root, we say, if it's in the numerator there, we say it's got to be greater than or equal to 0. So up there, x is greater than or equal to 0. Down here in the denominator, because you've got something down in the denominator down here, we have set it equal to 0, but then it cannot equal whatever's down there. So we're going to add 5, and we end up getting x equals 5. But then we got to say, oh, x cannot equal 5. So let's write our answer out here. Do their squigglies, do our such that. So x is greater than or equal to 0, but x cannot equal 5. X is greater than or equal to 0, but x cannot equal 5. So then I kind of want to do a recap here just to make sure we've got this all. So I'm going to come over here and do that. If it's a fraction with just a polynomial over a polynomial there, you want to set the denominator equal 0. And solve. And so then your answer there is domain is x such that x cannot equal whatever that is. Okay? The third situation here is you're going to have some square roots. And for square roots, you know, for example, whatever is underneath the square root there, you want to say it's greater than or equal to 0. And then solve. And so then you'll get x squared equal to something. If it's just a polynomial, so you just have these terms connected by addition or not addition, yeah, addition or subtraction. So like x squared plus 5x plus 6. You would just go ahead and just say that's all real numbers. And remember, we abbreviate that with a fancy capital letter R. All right, so let's move on to our second learning target. So we're going to go ahead now and simplify this. We've got x squared minus 1 all over x squared plus x minus 2. So what we want to do here is we want to factor the numerator. That's just the difference of squares there. So what's the square root of x squared? X. What's the square root of 1? 1. 1's a plus and 1's a minus. Down here in the denominator, simply factor that. What times what gives you x squared? X and x. What multiplies to give you a minus 2 and adds to give you a positive 1? That would be a plus 2 and a minus 1. So then what we do is we cross out anything in the numerator and the denominator that perfectly match. So notice the parentheses there is x minus 1, so we need an x minus 1 down the denominator. So you can cross them out. Notice I'm not crossing out the x's now and saying my answer is 1/2. It's x plus 1. I would need an x plus 1 down in the denominator in order for me to cancel out x plus 1. So my solution here is just x plus 1 over x plus 2. All right, let's try another one, letter B here. So let's factor the numerator. It looks like it's a difference of squares. The square root of 4x squared there is 2x. The square root of 1 there is 1. 1's a plus and 1's a minus. All right, now looking down there in the denominator there, I'm looking at all three of those terms and I see they have an x in common, so I'm going to take out an x. X times what is 6x squared? It'd be a 6x. Sorry, x times what is 6x to the third? It's 6x squared. Taking out an x here, x times what is x squared? It'd be an x. X times what is a minus x? It's a 1. Right, so I'm going to keep factoring this. We've got a 2x plus 1, a 2x minus 1, an x, and then we're going to factor this next part here. What times what gives me 6x squared? It's a 3x and a 2x. What times what gives me 1? It'd be a 1 and a 1. But we know 1 has to be a plus and 1 has to be a minus in here, and you're going to have to decide which one that is. The larger one here has to be a minus. So I'm seeing a 3x and a 2x. 3x is larger, so that has to be the minus. So a minus 3x plus a 2x will indeed give me a negative 1x. So what can we cross out? 2x minus 1s are going. Nothing else can cancel out because nothing else perfectly matches. You cannot separate. You cannot cross out the 2x and the x there because the 2x is connected to the plus 1 there through addition. So, all right, so let's go ahead and let's factor these. Just regular polynomials here. What times what gives us 2x squared? 2x and x. What multiplies to give us a minus 3? It's got to be a 1 and a 3, and 1 has to be a plus and 1 has to be a minus. It's got to be a plus 1 and a minus 3, because you get a minus 6x plus 1x will give me a minus 5x. And then what multiplies to give us a positive 18 and adds to give us a negative 9, so it has to be a minus and a minus, so it has to be a minus 6 and a minus 3. So then what can cross out? X minus 3 and x minus 3. So then we're just simply left here with 2x plus 1 over x minus 6. So now let's look at our next example here. X minus 2, can't factor anything with that. Let's come down here and let's look at this x to the third minus 8. So if you remember how we do this, we want to find the cube root of each of these. So we need to find our a term and our b term. So let's find the cube root there of x to the third. Well, the cube root of x to the third there is simply x. What's the cube root of 8? It's 2, because 2 times 2 times 2 is 8. So the way this goes, if you've got a to the third minus b to the third, when you factor this, it goes a minus b times a squared plus ab plus b squared. So our a is x and our b is 2, so let's fill that in. So it has to be a minus b, which is x minus 2. The second set of parentheses there is a squared plus ab, which is 2x, plus b squared, which is 2 squared, which is 4. So the x minus 2's can cancel out. So we end up there just with 1 over x squared plus 2x plus 4. All right, so now let's try this one here. So factoring this one, what times what gives you x squared? What multiplies to give you negative 10 and adds to give you 3. Next one here is the difference of squares. So square of the first term there is 2. Square of the second term there is x. One's a plus and one's a minus. Now notice we don't have anything that perfectly matches. But remember how this goes. That x minus 2 and that x minus and that 2 minus x are almost identical, but they're a little bit off. If you were to take a negative and you were to distribute through a 2 minus x there, you'd get a negative 2 plus x. If I were to distribute this through. So now if I took out a negative here, so if I rearrange that, it'd be x minus 2. So if you take a negative and you multiply by 2 minus x, you end up getting x minus 2. So normally our relationship between two of them when we cross out is 1 to 1. These are not going to be 1 to 1. This is negative 1 to 1, or 1 to negative 1, however you want to write that. So our solution there ends up being, you have a negative sign out here in front, and x plus 5 all over. I'm going to reverse the order of that 2 plus x and say x plus 2. Or you might say, I'm going to write it like this too. They just put the negative straight out here in the front. Just got to be careful of that, because if you get it too close to the x, it looks like a minus x plus 5. So next ones here are for you to try out here. See if you can do those. So you can just pause the video and then start it up again. Alright, so let's do these. X, x. Multiplies to give you negative 6 and adds to give you positive 1. It'd be 3 and a negative 2. Down here in the denominator, that's the difference of squares. Square root of x squared is x. Square root of 9 is 3. What crosses out? And so you end up here with x minus 2 over x minus 3. Over here we just factor these. Alright, what multiplies to give us a negative 3? It's got to be a 3 and a 1. So I've got a minus 9 plus a 2 will give me a minus 7. What multiplies to give me 2 and adds to give me a, well, what multiplies to give me 2? So it's got to be a 2 and a 1. but the negative ones need a negative, one's a positive. The larger product there has to be the minus, so because we got a minus 5 on the inside there, so this has to be a minus 6x, and this is a plus 1x, gives me a minus 5x. So what can cross out now? The 3x plus 1s. So we're left here with 2x minus 3 all over x minus 2. So our learning target checked. We had two learning targets. I can simplify reduce rational expressions, and I can define the domain for various functions. Those were our 2 learning targets. So your assignment there is to complete that worksheet.